Hello, dear Professor Ye, dear friends from many parts of the world. My name is Zhang. I'm working at Hunan University in China. I'm very happy to organize this session on alkali activated materials together with STEAM. Before the first presentation, I'd like to introduce what are AAMs and why they are so popular in today's research. When I say popular, I have evidence. There are thousands of papers published in the past decades, and among those most downloaded and most cited papers in the top ranking journals, you can always find a great portion are reporting AAMs. This week, I had a glance. There are 15 out of 75 most cited papers from cement and concrete research, cement and concrete composite, and construction building materials. The growth in the research community is driven by the wide acceptance of carbon neutral development for a sustainable future. As we know, cement and concrete are the largest man-made materials we are using today, and this is the energy input to produce 1 ton Portland cement, including calcination, milling, and overall electricity use. According to the materials and the energy input, the CO2 emissions factors, and the average CO2 emissions to produce 1 ton cement is about 640 kilograms per ton. So then times by the world production of 2.4 billion tons, and that's 1.5 billion tons CO2 emission, which equals to 8% global emissions. So to decarbonize the cement and the concrete industry, we're looking at different technologies and also including those various greener alternatives. AAM is one very promising. It can be produced simply by mixing reactive industry and waste and alkalis. We could easily get concrete by adding sand and gravel and these materials and activator together. Some previous analysis show that in the form of alkali activated concrete, the unit CO2 emissions could be reduced by 35 to 60%, depending on the materials you are using. When heated clay is used, for example, the efficiency may be not that high, but when slag and fly ash are used, the reduction efficiency is quite high. So, driven by the carbon neutral concept and the carbon tax, some demo projects have been completed in recent years, such as this West Camp Airport project in Toowoomba, Australia, where I lived before. The AAM concrete is called Environmental Friendly Concrete, EFC, by the local supplier. This is probably the largest AAM concrete application project in recent years. In 2015, there was another project, the construction of 6th-floor building. The structural elements, including beams and columns, they were produced by alkali activated slag concrete. In this year's Running Microdurability Conference, we received 24 quality presentations on alkali activated materials. This is a big contribution to this conference and also, of course, to the future development and application of AAMs. In this research, you will see those topics on hydration and workability, such as different raw materials, reactivity, biomass fly ash, phosphorus slag, and sometimes some are talking about the glass chemistry and working on the water to binder ratio, activator, and curing methods. There are 6 reports on the durability related topics, such as chloride diffusion in activated blended systems and chloride-induced corrosion of steel reinforcement and carbonation test for AAMs. For the mechanical performance, There are different shrinkage studies, creep strain and strain hardening behavior and modeling based on the micromechanics. There are studies on the fiber reinforcement and fracture toughness as well. So we don't have any report on standard, but we will have one in August during running week this year. It is a PhD course on AAMs provided by a group of researchers, including me. And let's wait for Professor John Provis for his introduction about the recent development of the standard. So I want to welcome you and thank you to join this special session. Now, let's welcome Steen to introduce his workshop. Thank you very much.